Alright, in this video we will continue learning how to graph rational functions. Functions with a polynomial in the numerator and the denominator. Alright, so for problem number 2 here, we're starting with the x-intercepts. When you don't have a number added on the end, like plus 5 or something like that, a shortcut that you can use to find the x-intercepts is to set the numerator equal to 0. Alright, but if I set this equal to 0, that's just going to give me x equals 0. That means the x-intercept is 0, 0. Now 0, 0 is on the x-axis and the y-axis, so that means it'll also be the y-intercept automatically. And we might as well plot that point. Now vertical asymptotes come from setting the denominator equal to 0. Alright, if I were to set this equal to 0, one way to solve it would be to factor it. So this is going to factor as x plus 3 times x minus 3. So that would give me x equals negative 3 and x equals positive 3. So these will be my vertical asymptotes. Okay, so x equals negative 3, x equals positive 3. By the way, make sure you write x equals in front of these numbers. Don't just put negative 3 and positive 3. Okay, so let's go ahead and graph those asymptotes. So here are my vertical asymptotes. Now let's talk about the horizontal asymptote. So anytime you're wanting the horizontal asymptote, you have to stop and look at the degree. You have to ask yourself which one of these three situations you're in. If the numerator degree is less, then the horizontal asymptote is y equals 0. If the numerator degree is equal to the denominator, then you divide the leading coefficients, and that gives you the horizontal asymptote. If the numerator degree is greater than the denominator, then there is no horizontal asymptote. So let's look back. The numerator degree is degree 1. The denominator degree is degree 2. So since the numerator degree is less, y equals 0 will be the horizontal asymptote. And let's go ahead and graph that. Alright, so there's our horizontal asymptote right there. Now it's time to plot a bunch of points. So let's type it into the calculator. Now I'm going to use the ask mode to pick my points. Okay, I choose my points by looking at the vertical asymptotes. So I have a vertical asymptote here at negative 3. So I could use values like, I'm going to need a few values on the left, a few values in the middle, and a few values on the right. I always like to use values that are very close to the asymptote among the other values that I choose. So I'm definitely going to pick negative 3.5, for example, since the asymptote is at negative 3. So let me just write a list of what I'm going to do. Alright, so I'm going to do negative 3.5. Alright, so that's just to the left of the asymptote. Just to the right of the asymptote would be negative 2.5. So I'm going to do that as well. Okay, looking at the other asymptote, if I go just to the left of 3, I've got 2.5. If I go just to the right of 3, I have 3.5. Alright, the order of these doesn't matter. So I'm definitely going to use those values. In addition to those values right around the asymptote, I'll pick a couple more here to the left. So negative 4 and negative 5 would be good. Alright, I'm going to pick a couple values here in the middle. Okay, so I'll pick -2 and +2. Alright, I'm running out of space, so I'm just going to add on extra boxes. Okay, so I've got -2 and +2. And I'll pick a couple more values over here, so 4 and 5. So, you know what, I'll just make an extra little chart. Okay, so these are all the values I'm going to do. So here I go, -3.5, and I've got this. So that's -2.2 if I round. Alright, I think you get the idea. I'm going to do that same thing with all of these points, so I'll do that off camera so as not to bore you to death. By the way, I'm losing my voice suddenly, so that's why I sound different. I'm trying to drink some tea, but I don't think it's working. So now I have all these values. I'm going to take these values and I'm going to plot them on this graph, obviously. Alright, and here's what it looks like with those points plotted. Now, the position of these points show me pretty clearly that there's a branch going in here. Alright, should look like this. Alright, there's a branch that's approaching this asymptote up high. And then passing through the horizontal asymptote and approaching this asymptote down here. And there's a branch going like this. Okay, so in the end your graph should look very much like this. Notice that you can cross over the horizontal asymptote. It is not a brick wall. The horizontal asymptote is just there to show you the end behavior. Now the domain is the x value, so we read from left to right. This graph goes to the left forever and it goes to the right forever, and it covers everything in between except for these vertical asymptotes. Every point, every x value is represented by a point on this graph, except for there are no x values at -3 and there are no x values at +3. So we just have to leave that out of the domain. So from -infinity up to -3 we have x values. So -infinity up to -3. We'll leave it round to show that -3 itself is not included in this domain. And then this middle area here covers the x values that go from -3 to +3. Alright, and this branch over here covers the x values that go from +3 to infinity. Alright, so there's your domain. And of course we'll connect these parts of the domain with the union symbol. Now the range, these are y values, so we look at it from bottom to top. We are not going to skip the horizontal asymptote here because, as you can see right here, we have a y value right on the asymptote, where there's a point right there at 0, 0. So every single y value is represented. The middle part alone goes from -infinity to +infinity. So the other two parts are just like extra. Okay, so the range definitely, this graph touches every y value from bottom to top, -infinity to +infinity. Alright, now increasing and decreasing intervals. Alright, I'm hoping you can see that this entire graph is decreasing. Alright, it's decreasing. As I go from left to right, I'm decreasing here, going downhill. I'm decreasing here, going downhill, and I'm decreasing here. Everything is decreasing. So basically the entire domain is decreasing. So I'm just going to wind up copying the domain again under decreasing intervals. There are no increasing intervals. Now in terms of symmetry, this is odd. Odd symmetry is where if you rotate the graph upside down around the origin, it would still look the same. So if you took this whole picture and turned it upside down, rotating around the origin, it would look the same as it does now. So that is odd symmetry. And that is it for number 2.